Have a good day, my friend. Okay, we'll start to now. I think we have explored to good extent the about the high side. I would like to then move to the low side operations. To start with, we can start with the connector that we saw earlier. We need to analyze that first. The output connector, what are the outputs that it gives, as well as what are the inputs it gets taken for the board to operate. Yeah, if you look at this, I figured out is there are from the one side, let's say 13-volt output is given for by 4 pins of that connector. That 13-volt output is used for different purpose. For example, for audio operation, the audio amplifier to work and all. And there are three pins has been grounded, and those are really connected together. And these are also, although they are 4 pins, they are connected together. And also this is the 5-volt side. This 5-volt gives to the directly to the video operations, because they are voltage, they are operating on very low voltage, uh, like 3.3 volt or so. And this 5-volt output is used for that. And there is another P on connector. This is the power on connector pin. And if you want to power up this PCB, when you switch on, if you disconnect the PCB and you just keep it as is, the uh, called low side voltages won't get activated. This peon signal is needed, which should be connected to the 5-volt to operate the power supply. Also, there's a B on, this called backlight on. The the backlight of the LCD panel doesn't on if this pin is connected to, if this pin is not connected to 5-volt. We should connect that to 5-volt to if you want to operate your television's LED back panel. Okay, there's no connection here. And this is the interesting thing, like this is the kind of PWM input taken from the uh, from the remote controller, because we in the remote controller we change the brightness from some controls. That comes as a pulse width modulator signal, and that gives the uh, input to this television, and television's video controller, like not the LED driver, to give the required brightness level is controlled via this. Yeah, if you see this, like this this side EPWM connection moves towards far away from the coil side. The reason is this IC. This is the one that controls the um, backlight LED, the LED backlights of the LCD panel. That driver IC has a different way it operates. Like as I explained earlier, EPWM signal is directly sent to the 7th pin, and with that it controls the brightness of the LEDs. And this is the backlight on signal. We need to make sure that backlight on signal given to 8th pin, so that it start switching on the backlight. Yeah, we pretty much understood what is in the connector. Now we need to make sure what are the other components involved in this board. Um, Actually, this is little difficult to troubleshoot, because there are SMDs, like surface mounted devices, all around. But if you carefully look through each element, you can get some sense how this works. Like there's a uh, N channel MOSFET here and two diodes coupled together here. It is called A4. This is the standard way of marking the um, surface mounted devices, and 2F, it is a PNP transistor, and there are a set of Zeners, Wi-Fi Zener, that is 12 volt Zener, and RK is the N-channel MOSFET, and also there is a shunt regulator which L431K you saw in the other side, that small transistor like thing above it is the um, shunt regulator, and there are many Zeners, like this is also a Zener diode, and this is another, I would guess it is a MOSFET, AP9967, and it is used for the, if you see, like the it directly taken from power from the transformer's output. If you see the here, the transformer's secondary side output, it directly takes here and pass through a diode so that the switching frequency is eliminated and DC voltage is taken out, and after that it gives to the um, source um, of the MOSFET, and the output is taken out from the drain, or in the other way around. I'm not exactly sure, but the circuit is different. Like this is not like the way the MOSFETs generally operates. The way they have organized is a little different. I will show what the differences are, um, because they try to optimize as much as possible so that the output power is saved, as well as the design cost is reduced. Yeah, it is a cool design, and these two are MOSFET that operates for 5 volt and 13 volts, and there are the few MOSFETs that give the power to LED panel itself. And yeah, pretty much we covered everything on this board, and yeah, let's closely look at what the how the circuit look like. This is the model number I searched for, that is BN4400504A, I guess. Yeah, in 04A, but this model number, the schematic of this model number isn't available in the web. The close match I found is this one, BN. If you search on the Google, BN004496B, it has some close matching things, but not exact. But it should be enough for you to troubleshoot. I presume. If you look at the circuit below, the MOSFET arrangements are really different. Really not usual way that is aligned in my view, like what we day to day, when we day to day do the whatever the circuitry, we don't find it easy to understand this operation, because this is power optimized as well as cost optimized. And these are the set of the connector I was earlier explaining, but this is not the cross match. This is only a cross match. 12 volt outputs and 13 volt outputs are there. And from the secondary side, it takes the outputs and take two set of surface mounted devices. You see uh, MOSFETs, and those get operated and produce the stabilized output. Yeah, since this was a cross match, I had to draw myself what the circuit was, but I'm presenting those because in case you got the same problem, or you were to troubleshoot this thing, uh, you could use these um, diagrams helpful. That's why I'm presenting this. Really, how this, uh, how I understood the circuitry without the schematic. I had to draw some of the surface-mounted devices and try to arrange how the map LED driver connected to the output and what the voltage levels that 5 volt taken from two diodes and all. Yeah, and also there's another diagram I draw to take it really easy to understand. Some of the values are given here. If you really want to get some understanding, you could get from these diagrams I present. Yeah, and the I think other like a symbolic form I try to draw it, but it is not complete. But you can get some understanding how the MOSFETs are corrected, how the P-on this uh, P-on has been implemented and voltages are connected. We get the voltage output from 5 volt and it feed to drain and not getting output from source like that. Yeah, I hope that is why these are the things I have today. I hope you enjoyed the video. Thanks for watching and put any comments on my channel. I really appreciate your support to make some videos in the future and make this useful for you. Thank you very much.